The Jericho-1 was one of the earliest ballistic missiles developed by Israel and represented a significant step in the country's effort to establish an indigenous strategic deterrent capability during the early decades of the Cold War. Developed during the 1960s, the Jericho-1 emerged from a collaboration between Israel and the French aerospace industry, particularly the company Dassault Aviation, which was also involved in the development of Israel's early missile and aircraft technologies. The program was influenced by geopolitical tensions in the Middle East and the desire to create a reliable strategic weapon capable of reaching targets across the region. Although much of the detailed information about the missile remains classified or based on open-source estimates, the Jericho-1 is widely recognized as the foundation upon which Israel later built its more advanced ballistic missile programs. Its development marked the beginning of Israel's transition into a technologically sophisticated missile power, demonstrating its ability to design, manufacture, and deploy long-range weapons independently. Technically, the Jericho-1 was designed as a short-range ballistic missile (SRBM) capable of delivering a payload over distances estimated at roughly 500 kilometers. This range placed it among the early generation of tactical and regional ballistic missiles that emerged during the Cold War era, comparable in concept to several other systems developed by major powers during that period. The missile used solid-fuel rocket propulsion, a significant advantage over many early ballistic missiles that relied on liquid fuel. Solid propellant systems allowed for quicker launch readiness, easier storage, and simpler operational procedures because the fuel and oxidizer were combined within the rocket motor itself. Once ignited, the solid propellant burned steadily, producing the thrust required to propel the missile along its ballistic trajectory. This propulsion design reduced the complexity of launch operations and increased the survivability of missile units by allowing them to remain ready for rapid deployment. The physical design of the Jericho-1 reflected the engineering practices of early ballistic missile development. The missile featured a cylindrical body with stabilizing fins at the base to maintain aerodynamic stability during the boost phase of flight. The nose section housed the payload and guidance components, while the main body contained the solid rocket motor and structural elements needed to withstand the stresses of high-speed acceleration. During launch, the rocket motor ignited and generated intense thrust, rapidly accelerating the missile upward and forward. This initial stage, known as the boost phase, lasted only a few minutes but was crucial for determining the trajectory and final range of the missile. After the rocket motor burned out, the missile entered the mid-course phase, during which it traveled through the upper layers of the atmosphere following a ballistic arc determined by physics and the initial launch parameters. Guidance systems for early ballistic missiles such as the Jericho-1 typically relied on inertial navigation technology. This system used gyroscopes and accelerometers to measure the missile's orientation and acceleration during flight. By continuously calculating its position relative to the launch point, the missile's onboard computer could maintain the intended trajectory. In the 1960s, inertial navigation systems were far less precise than modern digital guidance technologies, which meant that early ballistic missiles generally had lower accuracy compared to contemporary designs. However, even with these limitations, the Jericho-1 represented a significant technological achievement for its time. The ability to deliver a payload over hundreds of kilometers using an autonomous guidance system demonstrated considerable expertise in aerospace engineering, electronics, and materials science. Another important aspect of the Jericho-1 program was the development of mobile launch platforms. Mobility is a key feature of many ballistic missile systems because it increases survivability and flexibility in deployment. Instead of being confined to fixed launch silos that could potentially be targeted by adversaries, mobile launchers allow missile units to relocate frequently and operate from a variety of positions. These launchers typically consist of heavy military vehicles equipped with hydraulic systems that raise the missile into a vertical launch position. Once the launcher is stabilized and the missile is aligned, the launch sequence can begin. For a system like the Jericho-1, mobility provided a practical means of ensuring that the missile force could remain operational even in the face of potential threats. The development of the Jericho-1 must also be understood within the broader geopolitical context of the Middle East during the 1960s and 1970s. Regional conflicts and shifting alliances created a security environment in which many nations sought to develop or acquire advanced weapons systems. Ballistic missiles offered a means of projecting power across long distances and served as a strategic deterrent by demonstrating the ability to strike high-value targets. In this environment, the Jericho-1 became a key component of Israel's emerging strategic doctrine. Although the missile's exact operational history remains largely undisclosed, it is believed to have played an important role in establishing the technological foundation for subsequent missile systems. Over time, the Jericho-1 was gradually replaced by more advanced systems such as the Jericho-2, which offered greater range, improved accuracy, and more sophisticated guidance technologies. The transition from Jericho-1 to Jericho-2 illustrates the evolutionary nature of missile development. Instead of discarding earlier designs entirely, engineers typically analyze the strengths and weaknesses of existing systems and then introduce improvements in propulsion, materials, and electronics. In the case of Israel's missile program, the experience gained from the Jericho-1 project contributed directly to the development of later missiles with far more advanced capabilities. From a technological perspective, the Jericho-1 represents a significant milestone in the history of ballistic missile engineering in the Middle East. The program required expertise in several complex disciplines, including rocket propulsion chemistry, structural design, guidance electronics, and high-temperature materials capable of withstanding the stresses of atmospheric re-entry. Developing these capabilities during the 1960s required substantial investment in research and development as well as collaboration with experienced aerospace partners. The success of the program demonstrated that Israel had achieved a level of technological independence that would allow it to continue advancing its missile and aerospace industries in the decades that followed. For viewers of Driven Vision, studying the Jericho-1 missile offers an opportunity to understand how early ballistic missile systems were designed and how they influenced the evolution of modern strategic weapons. Unlike many contemporary missiles that incorporate advanced digital guidance systems, composite materials, and highly optimized propulsion systems, the Jericho-1 relied on comparatively simple but robust engineering principles. Nevertheless, these early technologies laid the groundwork for the highly sophisticated missile systems seen today. By examining the Jericho-1's propulsion system, flight profile, structural design, and historical context, audiences can gain insight into the origins of modern missile technology and the strategic considerations that drive its development. In summary, the Jericho-1 ballistic missile was a pioneering system that played a crucial role in establishing Israel's early missile capabilities. With an estimated range of around 500 kilometers and a solid fuel propulsion system, it represented a practical and reliable weapon for regional deterrence during a period of intense geopolitical tension. Although it has long since been replaced by more advanced systems, the Jericho-1 remains an important chapter in the history of missile development. Its design, technological innovations, and strategic significance continue to be studied by defense analysts and historians who seek to understand the evolution of ballistic missile technology and its role in shaping modern security dynamics.